Next, we'll see how verification of boundary values can be applied in this example. An input factor like age has values that are ordered. It has a minimum value, a maximum value, and values between. In contrast, the sex values are enumerated. There is no ordering there. When factors are ordered, and when they determine equivalence classes, developers must implement the boundaries. They are work areas where errors are introduced sometimes, so the boundaries need to be verified. In the BMI example, there is an age boundary between the Medicare classes, and another one separates both the child and adult classes. We can generate test cases to verify the age boundaries by replacing the previous values with boundary values. But the age input is not the only equivalence class boundary. There are BMI boundary values. They are not test inputs, but they depend on inputs. Can we verify the BMI boundaries using embedded functions? The answer is yes. Here is the formula for the BMI in terms of the input factors weight and height. What we need is input values that reach the BMI boundaries. Let's try the weight input. If we solve the equation for weight, we can express its input value in terms of the height input and the BMI boundary value. Here's how it can work. We'll continue to use the height values 64 and 71 inches, and we'll introduce a BMI boundary factor to specify the boundary. There's one more detail. The weight input needs to be an integer to generate either the minimum BMI value for the higher class or the maximum BMI in the lower class. We'll introduce an input limit factor to specify which limit to use. This weight boundary function specifies the input values for the weight factor. It depends on the height, BMI boundary, and input limit factors. It uses the weight formula above and rounds up to the next integer. This value is returned for the minimum value in the higher BMI class. The next lower integer is returned for the lower side of the boundary. This is a graph of the possible BMI boundary values for this example. The weight boundary function has 3 arguments: height with 2 values, BMI boundary with 3 values, and input limit with 2 values. Their product leads to 12 weight values corresponding to 12 BMI values. This means that regardless of how many test cases are generated, each will correspond to one of these BMI values. This request generates test cases for age boundaries and for BMI boundaries. The age factor has its boundary values. The height, sex, and intake factors have the same values as before. And we have the 2 new factors, BMI boundary and input limit. The weight input values are given by the weight boundary function. It's a combination function, so it will be evaluated for all combinations of its arguments, and its values will be paired with the other factors. We keep the same equivalence class functions, but they're substitution functions now. They just report the expected output classes for convenience. We don't need them to cover the classes because the boundary value factors will do that. Once again, we paste the request from the previous slide into the request form and then click the Submit button. "48 test cases are generated.